usually post them to Germany Power Platform YouTube channel. Also join us on Meetup whenever you can and check what is coming next. So your hosts, like pretty much every week, myself and Christian. So if you need anything regarding the user group, any ideas, suggestions, just reach out. Somebody pretty loud. Events which are coming up in October. So this is the last session for this month in October. We have a few really interesting events also coming in. You can see it on 6th of October with Mark and external tools, 13th of October, Ferenc and XMLA read-write endpoints, and 20th of October, Daniel Oettinger with deep dive into tabular editor. So it will be like September was and will be today. October will also be a pretty exciting month regarding the Power BI user group. And for today, pretty much I would announce it like this. So if you want to become a superstar, you first need to learn some things in Power BI. And to guide you through it, I wish a warm welcome to Markus, and he will guide you today through his famous session, Model Your Data Like a Star. Markus, thank you again for joining, and stage is yours.
Thank you very much, Augustine. Yeah, welcome to the session. And maybe you recognize or not, but there's pun intended. So it's both, the star means both that you can be a star by doing the modeling right, but also the model should look like a star. And whatever this is, we will talk about in the next about 60 minutes. I will try to share my screen. So please let me know as soon as you can see my slide deck.
Yeah, we can see it.
Okay, model your data like a star. So my name is Markus, and I work with models. And if this is still from another session. Sorry for that. So my name is Markus, and I work with models. And if I tell people that I work with models, they have maybe some different things in mind. So many people think that I work with beautiful people, those models, but I work with data models. That means, yeah, tables, and there's a relationship between tables. And lucky enough, in Power BI, we have the possibility to build a data model. In other tools, we don't have. And this means this is a little bit like the learning curve is not really straight, but like there's a step you have to overcome to understand what a model is and why it is important to get this right. And in the end, after you have understood this offers plenty of opportunities. So this was, it might be harder to learn Power BI because you have to take care of a model. But as soon as you can do much more things than in the other products, in the other vendors, other tools which are out there on the market. So I'll have to open up the chat window again. For some reason, if you share the screen, then Teams always changes the screen here. So if there are any questions, please unmute yourself, interrupt me, or write into the chat window. I hope Augustine can help me to track the chat window. If I'm not paying attention, it's not I'm ignoring you. It's just because I didn't see that you wrote something there. So the agenda again, Power BI Desktop. Why is Power BI Desktop like it is? And Power BI Desktop is built or is born as a self-service BI tool. So this started with an add-on to Excel. Maybe some of you know that there's still Excel Power Pivot out there. There's this data model and Power Query in Excel. And Power BI Desktop, even before Power BI Desktop was a thing, there was already Power Query, Power View, and so on as part of Excel, which was like the pre-version of Power BI Desktop as we know it right now. So it's a self-service BI tool. And with that, it tries to make your life as somebody who has to work with data easy. And the way it does this is to make educated guesses. So if the tool can find out what you really need, what you really want, it will build it for you. But this comes at a price, because those guesses can be right or they can be wrong, or yeah. And so sometimes there are pre-defaults in Power BI, like the auto date time things we'll talk about, which is really cool for people not knowing anything about Power BI, because then they can build reports with using time intelligence function tags. But as soon as you start coming a level up, then you maybe don't like this anymore because it takes out flexibility. You want to build things on your own. So there's like always an outbalancing. So the product team at Microsoft has really outbalanced the users. On the one hand, targeting, make it really easy for people who don't want to learn too much about the tool, but also giving a lot of possibilities to people who want to understand and would do more than the defaults and really make wonderful things. So, and for this is the Power BI data model is so important. So we talk about three things. One is relationships. And I mean the relationships between the tables. It's not a private talk about your marriage or whatever. It's relationships in the data model where we have relationships, and about denormalizing, which is an awful and awkward term, I would say, when because like even normalizing, this is awkward, but denormalizing is like awkward to the next level. And I will talk and explain what I mean with that. And this is really important that you understand this concept. And then we'll look at the data dimension, because I think the data dimension is the most important dimension. In many data models, there will be a date-related data, right? Your facts, your transactions. That's the events in real life usually have a relationship to some point in time or a day and so on. Therefore, the data dimension is so important. That's what we'll talk about that. And most probably for today, I will take more time on the relationships, normalizing, and date dimensions. So most probably there will not be space for the use cases afterwards. But this is not that bad, because by a chance, this was not planned in this, but there's also another meetup today, like in what is it? Like in in 1 hour 50, right? 1 hour 20. There's another user group meeting, and they selected like the advanced data modeling. So this the other meetup today, like after this month, there's a break, and then the other one would start it. Ping me if you need the meetup. So shameless plug for the other meetup here. And I will talk about the advanced things, and there I will also show the use cases. So maybe we have more time now to really get the basic and the concepts right, and really understand what's happening there before we bring it to the next level. Okay, with that said, let's start with relationships. So the relationships, if you open up the Power BI model view, then you see like those tables, and they have like lines in between. And if you heard something about databases, maybe you have a degree in IT or not. If you have, then this will remind you of foreign key constraints in the database. But it's slightly different. As the name already says, foreign key constraint. A constraint is something limiting the possibilities. And in the database, I put in constraints to increase the data quality, right? So I don't allow anything to put in, like when I have like a transaction and somebody has to put in a customer ID, then of course this customer ID has to be existent in the customer table. I cannot refer to a customer which is not existent. So therefore I put in a constraint in the database to limit the values, the possible values I could put in the field customer ID. There are only values allowed which are also available as an ID in the customer table. This is really important for increasing data quality. Here it is the other way around. So if you connect to a relational database and you have foreign key constraints, at least they are there, even if they're not enforced. But if they're there, then Power BI will read this information and create relationships in your data model. And this is cool because for business reasons, for business intelligence reason, this is a good thing because, but it's not a constraint. So Power BI data model is not a database where you can insert values and those values then are checked. When the only way to insert something in Power BI or in analysis services is to load everything, or at least load the last partition. You can partition things, but you cannot update things. So there's no danger that something gets wrong. So we don't need a constraint, but what we need is the other way around. The relationship and the relationship between two tables means if I select one customer, for example, I have a filter on a customer, or I have a matrix or a bar chart or whatever, and put my customers on the axis, I won't only see the sales or quantities or whatever for those customers. And that's what this relationship is needed and used for in the data model. So it's not a constraint on the sales table, but it offers the filtering. If I filter and select one of the customers or a year or a product, or whatever your dimensions are, the things you want to group and filter by, this will then filter the sales table, the transaction table, and limit to this customer, to this product, to this year, to this day, whatever. So this is important to understand. It looks like constraint, but it's not a constraint, but it's still very, very important that you get this right. Because, for example, if this relationship is missing, then you select the customer, but if you didn't tell Power BI via the model that there's a connection between, if I select the customer, I only want to see, I want to limit the rows in the sales table. If you don't do that, then you can select the customer, but nothing will happen. Then you end up with a report that you have, like, for example, a bar chart, see all your customers, and all your customers show the very same number. They show the total of, for example, the sales or the quantity. This is because then the customer is not filtering the sales table. So this is very important that you get right. Power BI is helping a little bit, so it tries to find out about those possible relationships, but it's now more like conservative. That means it only creates these relationships for you if it's really certain that it makes sense. And still then it can fail. So for example, if you're connected to a relational database, if there are foreign key constraints, they will overtaken and then you get the relationships there. If you load, for example, from Excel spreadsheets or a website or whatever, then there is, of course, no relationship. There's no foreign key constraint. You cannot, foreign key constraints are not possible in Excel. You cannot define them. But it still will try to find out if there's a relationship possible. And it's very conservative. So it's checking that if the column names in both tables, if they are the same. That's the first thing. The second thing is it checks if the data time is identical. So if there's two columns, but they have different, like one is a date and one is a string, it will not connect it. And the third is if the cardinality is fitting. So it looks up if in one of those tables, this column has distinct values. So there's only unique values, there's no duplicates. And the other maybe has duplicates. Then it will create a one-to-many relationship. We'll talk in a minute about that. Is there somebody talking to me, or is it just a background noise I can hear? Okay. Is there any questions here again from the people? Then Augustine, yes. Thank you very much to put in the link in here. Very good. Okay, no other questions. So it is important that we have, and Power BI will help you, but I've seen situations where this does not work. For example, maybe all your tables have a column called ID. Then it will join those tables with each other with the ID, but maybe the ID in the customer table is something different than the ID in the product table, because then it's the customer ID or the product ID. And then it will mix things up, which is not good. So you also have the possibility to turn this off. This is often what I do, that I turn this off. But the long story short means take care of the data model. Really look what's out there. Even if it's automatically created, check it if it's right, if this makes sense. The second thing we have to think of is the cross filter direction. So the filter, I just explained that if I select the customer, it will then, for example, limit my sales because there's a filter running in this direction. And this filter direction by default is only in one direction. So it's always going from the customer to the sales, from the one to the many side, as we will hear in a second, the cardinality. And I can change this to bidirectional, so also the other way around. And there are real use cases for that. I will talk about that in the other meetup. There are, I think this is a use cases which are not use cases. This is when you want to filter cascading filters. So if, for example, if you have like a sales table, you have the values there, and then you have a date, and you have like products, and then somebody selects a year or a date, and then still the product table shows, or the product slicer shows all the products available. So there's the chance that I select a year and a product, and then I see nothing because this product was not sold in this year. And some people solve this by putting bidirectional filters between the date and the sales table and between the product and the sales table. Please do not do this because this bidirectional filter makes your data model slow. The number one reason why Power BI is slow, even if you don't have very much data, is because the data model is too complicated. And bidirectional filter for this reason is too complicated. Don't do that. Okay, get data. Is referring to something I talked about, get data. Please let me know. Bidirectional, but I can solve this differently. So I could instead put an additional filter on the slicer to ask for only show values if there's a sales available for the current filter context. So think about that. The second, or the last thing here is the cardinality. Again, a term I would never use in real life. So this is like a very technical term. So this could scare people away. What is cardinality? And that is basically 3 different cardinalities: one-to-many, one-to-one, and many-to-many. And that means, if you're coming back to our example with the customer and the sales, this is a typical one-to-many relationship. Because if I take one row in the customer table, this one row in the customer table, the ID of the customer, can appear several times in the customer ID row column in the sales, right? One customer can have many sales. Hopefully, we sold many times to the customer, right? On the other hand, if I look at one sales row at one transaction, so think like in the supermarket, bleep, yeah, this invoice it generates, this cell here, only can be assigned to one single customer, right? So one invoice, there's just one name on it, or this is like one product or whatever. The company cannot be several customers assigned to one invoice. So that means that we have a one-to-many relationship, because one row here can have many in the sales table, but the sales table can only refer to only exactly one customer. So we have one-to-many relationship, and that's what Power BI is built for. So when in doubt, always build one-to-many relationship. If this does not work, then we have maybe a data quality issue. So if the duplicate rows in your customer table, because only one, it's enough if only one customer appears 2 times there. So the customer ID is not distinct, but you have 2 rows with the same customer ID. All the other customers' IDs are different. Then Power BI will complain and will not allow you to make a one-to-many relationship. So instead of then using a many-to-many relationship, which Power BI will suggest, go through your data quality and check out why this didn't work. The one-to-one relationship is really rare, because it means I have 2 tables and one row here has one row also there. Usually would just make one table out of that, right? Because why would I have 2 tables? The only reason I could see is that you would have you want to refresh those tables independently. So one is refreshed from one, and like you want to have another schedule than there. If you want to independently refresh the things, then you might split it up in 2 tables. But this has the disadvantage that now there's a join. So Power BI has to find out and look up the rows in the other table, which is slower than having everything in one table. And also the user interface, if you look up at the fields list, you have the tables and the fields list, then there's 2 elements like customer and customer details or whatever. And then you have to remember, if you look up the field, is it in customer, is it in customer details? So it's more complicated for the user. And keep in mind, why do we build, even if you're coming from the IT department, why are we building analysis services databases? Why are we building Power BI reports and data models? Because we want to make the life of the of our users who have to work with the data and make decisions on it, they should have an easy life. So never build a complicated model, make it easier for them. This is the only reason, because if it can't be complicated for them, why would you build even analysis services or Power BI? Just learn them SQL and let them write SQL statements against the relational database. But that's usually not what they can and what they want and what we want them to do. They need an easy way to access the data. So there's a lot of things happening in the chat. If there's something I should answer on, please let me know. Otherwise, I will concentrate on my talk. And the cardinality means if I say one-to-many, the one could also be theoretical, could also be 0. So there could be like a sales which cannot be assigned to like a ship date, because currently it's ordered, it's not shipped yet. So there could be no ship date assigned there. So the one could also be 0. The important thing is that it can be unique, and the many also can of course mean if I have a brand new customer, this one customer doesn't have any row in the sales table, right? But that's not what we're talking about. Many means theoretically, potentially the customer can have many. But it could be have that one customer, because it's brand new, doesn't have a sales now, or just one because it was the first order. But this is not what we're looking for. We're looking not for extremes, but for the usual thing, that one customer can have many sales roles. With that, we're coming to our first demo here. So what I brought here is, of course, this is not the model view. This is the data view. And this is the report, and I have 2 tables here, and I want to demonstrate the one-to-many relationship. Somebody talking to me? Okay. So I have the transaction table and the account table. What I can't see here really is what's the relationship. So maybe go over to the relationship view, and then we see the one-to-many example here. Making more space here, and then we can zoom in. So there's just two tables we're looking at, and there's the transactions and the account. Think of a bank account. So one bank account can have, of course, many transactions. That's what we're seeing here. So one account here can have many transactions. That's why we see the star here. The star means many. On the one hand, one transaction is clearly assigned to one of our accounts. It's not possible that the same transaction, the identical transaction, is assigned to two accounts. The transaction is only assigned to one special account. And that's what we can see here. So there's this one-to-many, and we also see like this filter direction. We see a flat side and a pointy side of this triangle. So the flat side means this table is filtering the other table. We can also like always double click there, and then also see the details and change them. So we get this window here, and if I zoom in here, edit relationship, then we see there's this cardinality. So the star 1 means the star and the one of this set. Be careful, this depends on the order up there. So this is a many to one because first we see the transaction and the account is here. That's why it's a many to one. So if you choose this, there's a one to many and a many to one. Always choose the right one depending on the current order of your tables, and you see the tables up there. And the other one is this cross filter direction. This can be single or both. Please stay away from both as long as you can. And if you think you need both, talk to your peers, talk to your colleagues, and discuss if it's really necessary, or you can find a way around, because your performance will suffer and your model gets more complicated. In some point in time, maybe you cannot add another table with the same principles, because then you get like an ambiguous model, and it will not allow you to build an ambiguous model. So that means with the filter cardinality, we can also see, if I go there, if I filter, for example, if I click on Bill, then I can see, if I click on Bill, then I can see now the transactions are filtered down to account ID 11, right? If I click on Jeff, account ID 12, then I see there's a filter happening. So the filter is only going in this direction. That means if I click on one of the transaction, nothing happens over here. So if I check anything here, the filter is not going in the other direction. And this is okay usually, because I filter on my date, on my dimensions, product, and so on. But I don't need a filter propagating from my fact table, which is a huge table, to the other one. But maybe say, wait a moment, Markus. You just said if I click on the account, it's not filtering, but I can clearly see that if you click on the account, that like this table up there is filtered. So what's the truth in here? And the thing is that there's many possibilities that filters are applied. So what I'm currently talking about is the filter in the model, the filter direction in the model. But there is also a filter between visuals, the cross filter. Maybe you heard this. By default, this is turned on. That means if I click on any of my visuals, it will filter all the other visuals on the same page. And this is what we're seeing here. So it's by intention, I let this here so we can discuss this. So there's different things that will propagate filters. One is from the model, but also the visuals are filtering each other. So sometimes it's hard to understand what's happening or hard to believe because there's several things. I mean, this again, good intention, because this is a nice feature. I click somewhere and then all the other visuals respond. But understanding what's happening in the model makes it harder, because then somewhere there is a filter applied, even if it's not coming from the model. And yeah, there's also the one-to-one, which is not so common, I would say. This means that by default, there's always a bidirectional filter. So I think this is the only way we can set this up in Power BI, I believe. So if I select one in one table, it automatically filters also the other table. And there's these different combinations then of one-to-many to one, for example. So I could have an account, and the account has transactions, but the account has also customers assigned to it. So I have an account customer table where I see different accounts, and some of the accounts are coming here twice because different customers are assigned to them. So there's more than one customer who has access to the account. So you can share, for example, one of your bank accounts with your wife or your partner, and other accounts you only own exclusively. So this is possible. So there's one customer can have many accounts, but also one account can have many customers. This is not what we're talking here. This is a one-to-many to one relationship. That means I have a relationship between transaction account and the relationship between account and customer. Again, if you look up the cardinality here, then we should see like a one-to-many in this direction, the one-to-many in this direction, and this triangle is always pointing from account to the other tables. That means if I select an account, of course, the two other tables will be filtered. But if I, for example, select this transaction, it will not filter the account. As the account is not filtered per transaction, also the account customer is not filtered. And also the other way around. If I select something account customer, it will not filter the account, and therefore also the transaction is not filtered. Any questions so far? Thanks. Okay, you're discussing several things. I will read through them later on, maybe, if there's time at the end. So denormalizing. What kind of model should be built? Now we know theoretically there's filters, there's filter directions, there's cardinality, but what kind of model? How do I know how many tables I need, and how should the tables be connected, and so on? So that's about the normalizing and denormalizing. So let's start at the naive approach. So if you ask me, Markus, please give me a table, please give me the information like a list of all the products and their subcategory and the category with the sales amount for a certain year, then I most probably will give you one single table with 4 columns: the product subcategory, the category, and then the sales amount. This is like the easiest to understand. And many Excel spreadsheets are built like that because that's what we see and can read. But the problem here with this table is redundancy. So if I have a product category which has more than one product, then the name of the product category appears several times on this list, right? So if I want to change the product category name, for example, I have to make sure to change it on all places, because otherwise I end up with like bike and bikes. In the real world, this would be the same, but I have like a typo at one of the rows. So this is not so good for updating, inserting, deleting. So all the relational databases, so Edgar F. Cott, not sure if you ever heard about this guy, he invented relational databases back in 1970. So this is, relational databases are even older than me. I'm starting to get old, but the relational databases are even older. And he designed not also those complexities and those things with relations and tables, but also thought about normalizing. So because it's not a good thing if I have to update several rows. It's better if I only update in one place, because otherwise, if I don't do it right, we have this anomaly that things are getting apart. I have 2 different categories which are in real life the same. Also, I have the problem when I'm inserting something in this table I just mentioned. If I have a new product category, but there's no subcategory or a product assigned, how would I insert this table? Like, is the product then empty, or is there a placeholder, whatever? And the same appears if I delete something. If I delete a product, and this product happens to be the very last product of this category, if I don't pay attention, I not only delete this, when I delete this row, then I not only delete this product, but also the information that this product category exists. So there's those anomalies. And that's why application databases, so for example, your banking system where you type something in, or any application which gathers data, tends to not use the single table because it's too complicated. It's slow for updating, inserting, delete. And we want to have it easy, and we want to have a good data quality. So what we do here is we normalize the schema. And sorry for the term, I did not invent this, because I think, man, what's normal, and how do I change something to normal? I mean, would this be normalizing? I'm not sure where this, this term came from Edgar F. Cott, but I'm not sure why he came up with exactly this term. It could be anything. And the goal of normalizing a schema is to avoid redundancy. So I would then split up this mentioned table with the product subcategory, category, and sales. I would split up. So I would have one table where I have my sales in there and a key to the product table. And the product table would be a separated table with the product key, of course, and a key referring the subcategory table. And there's a subcategory table with a subcategory key and a reference, a foreign key to the product category table. And the product category table only has the key and of course the name. And also the others have, of course, the name in it. So I would split this up with the advantage that, for example, all the product categories I'm having only appear once. So there's only one row telling me bike. And if I change this to bikes, I just change it on one place. And if I build the query again, my report, on all the occasions that I get bikes instead of bike. If I delete a product, I don't have no product subcategory or product category will be deleted. If I want to insert a new category without assigning a product, easy. I just insert in the product category table. So that's the mindset behind it. And that's what everybody gets taught on university. If you have like some database or IT engineering course, then you'll learn about redundancy and avoiding them and normalizing the schema. The backdraft of the older concept is, for querying, it's really, really hard because like in this simple example, I have to first query my sales table and then use the key in there to find the product to show the product name. And I also have to use the key to then use the subcategory in the category table. So I have like a long query where I have to specify, I want to take information from these 4 tables and I somehow have to join them over a key. So writing the CBOS table is much longer. So this is more error prone. I have to have more understanding, and there's the bigger chance that something gets wrong here. So that's one of the first disadvantages. The second advantage is not only me has more things to type, but also the database has much more to do because it has to find the rows in my sales table, and for each row there, it has to find the rows, the fitting row in the product table, and the same to the subcategory and category table. So the query tends to be slower. It's more complicated to use and it's slower for querying, for business intelligence. So that's why for data warehousing, we try to find a sweet spot in between. So the single table would be really easy to generate, and some tools even use the single table approach, but it's somehow unflexible because of different granularities and things like that. So that's not optimal. The normalized is also not normalized, optimal. So there's something in between. And now we have this awful term normalized, but now we have on top of it, we have denormalized. And it does not mean that we're going back to one single table where we have the full redundancy, but we think about what kind of table this is. We distinguish between facts and dimensions. So what are facts? Facts are my transactions. So every real world event is a fact. So this might be the beep on the supermarket. That might be some IoT device sends some information over. This might be that the car discovered some signs, whatever. Real world events. That's our facts. And on the other hand, I have dimensions. So I have things I want to group by. I want to filter on, for example, the date. I want to group by or filter by year, by month, by week. I want to filter by my product, subcategory, category. I want to filter or group by my customer groups. Those are my dimensions. And then we can build star and Snowflake schema, which will come in the next slide. So single table would be one broad table. So even if there's like this is underneath each other, those are column names. So single table would mean I have one wide table. Don't do that in Power BI. Power BI is not optimized for that. Power BI is optimized for the denormalized schema. So this is one reason. And if there's time at the end, I can show you that in some circumstances, not sure that you get hit by that, but if you have one single table and you put filters on this, that the results you see in Power BI in the report are wrong. And I mean, nobody wants to have wrong reports, right? And this only can happen in the single table. So please stay away from the single table unless it's really a very simple thing. But you never know, it can always get more complicated. So don't put the single table. Also, the compression suffers really. So the file size and the model size will be huge compared. So a factor like 2 or 3 times depending on your data. So bigger model, and maybe you get wrong numbers out of it. So stay away from the single table. So what should we do instead? Normalized we don't want, but we can build star in Snowflake schema. And with the star in Snowflake schema, we have dimensions. Again, this is the things we want to group by on. So this is how something happened, what happened, when did it happen, where did it happen, who was involved, why did it happen, is there a reason for something? So the reason why the customer bought something, for example. This what you could save, and then this is then put into dimension tables. So it's a certain type of tables, so to speak. Of course, in Power BI, it's the same table. I mean, technically, it's the same thing, but from a model perspective, it's something different. And the rows in there, or the information there, we use to filter and group on. Compared to our fact tables, those are comparably small. Think of a data dimension having 1 day per, so 1 row per day of a year. If you have 10 years, it's not even 4,000 rows. If you're not have consumers as customers, most probably the customer table has few hundred, few thousand rows. So no issue here. Or the products, for example, depending on the business. Of course, this can be different. So I worked for a company where we have like end users, and when I started there, the user table was, the customer table was 100 million rows, and at the end, when I left, there was 200 million rows. So this was a big big table, no matter. But the fact table was even bigger. So it's relative. And those dimension tables are always on there. Somebody making noise. Please, can you mute yourself? This would help me to concentrate. Thank you very much. So on the one side, just on the one side, so I have one day, and for one day I have many sales, and every sale, every transaction I can assign to exactly one day. Those tables usually have not usually, they have to have a primary key, which I can refer to from my transactions. And then I have a lot of columns. So usually they are wide, and usually columns of all type, most probably it's text things. So for example, product name, category name, subcategory name, address, the week, can be numeric, but usually it's like text things. On the other hand, I have my facts. Those are the real world events, transactions, and they measure things. So I have like a sale amount, I have a quantity in there, I have a special price, which was assigned during like a process, and then like we bargained about the price. So there's price information there, things like that. I use those tables to aggregate things. I'm usually not so much interested in one single event, like in one customer and one product. It might be that I have reports on that I want to see the detailed transaction, but usually we aggregate. We want to know what was the sum of the sales for one day. What is the average of the order quantity by this customer? When was the product was the product last sold, or when was it the first time sold? Things like that. Compared to the dimensions, usually the transactions are much bigger, and they're on the many side. So there's many transactions for one day, for one customer, for one territory. And those tables usually only have numeric columns. So the key should be numeric because it's better compressible, so it will be faster. Also, the joins will be faster, and the rest should be usually are only numeric columns. So this is like a quantity, this is a sales, this is a price, no text. You should avoid to put text in there. And the reason for this is because fact tables are so big. We don't want them wide, we want them slim, because every byte I add here, every information I put directly into the facts. So every byte I add here, you have then to multiply by the number of rows to get the final size of this table. So if we have 1 million rows and we add just 1 byte of information, it means it's 1 megabyte. If it's not 1 million rows, but 1 billion rows, every byte we add here is 1 gigabyte. And if it's like then 20 bytes, then it's 20 gigabytes of size in the model you increase. So we don't want to do that. We want to really be greedy what to put in the fact table. And if you put something there, it's mostly just an integer, whole number referring to the details. So all the address of the customer, like all the information of the date, like the year, month, week number, day name, month name, whatever. I put only in this dimension table because this is just 400 rows per year, not even. And then I'm referring this from the fact table. So this is the principle why we distinguish those tables. So we denormalize the whole dimensions. So we put everything in there because they can be wide, no problem at all. But for the facts, I am not denormalizing this. The fact table is still normalized. Any questions about it? What we have normalizing is relational modeling for transactional system. Yes, denormalizing is dimensional modeling for analytics. Exactly, Kerry. You tell the entry that you have in the one sort of relationship. When you adjust the data. Yeah, okay. So the discussions there. The star schema could look like that. Again, why is this called a star schema? You need a little bit of fantasy, then you could like a three-pointed star, right? I know you need some fantasy for that, but this would be the star in here. So I have like the fact table in the middle. This is the fact table. This is only on the many side. Here I still use fact, reseller sales, and dim product, dim date, dim sales territory. From a naming perspective, this is bad. This is bad. Why are we building those models? For the end users. Do the end users care about dimensions and facts? Most probably they never heard about that. They only get confused. So I still see people building models where in Power BI or analysis services, still there's this dim or fact prefix in the table name. I would not do that. Just name it date. Just name it reseller blank sales. Use natural names, user-friendly names. Also for the columns. The columns are the default names then for your columns or axes or whatever in your visuals. And you do not want to rename them all the time. So it's better to have them in the right name already in the model. So this would be a star schema. And it's not a star schema because I arranged those tables, but like because I have one table in the center where it's only on the many side and the others on the one side. So also I've seen people with taking a normalized model and just putting one random table in the middle and then it's surrounded by all the other tables. This is not a star schema. Star schema is because I have one table here in the center on the many side and then it's surrounded by one ring of other tables. So I have a reference from the factory sales to the product, but not from the product to the other further. So this makes a star schema, that those dimension tables don't have a foreign key. They don't refer to anything. They already have everything in there. So the product table has the product name, the subcategory name, and the category name. And if you tell something like that to an application database developer, they will have here's like this. No, this is redundancy. We have to normalize this. Yes, you can do this, and then we would be in a Snowflake schema. So Power BI doesn't really care from a technical perspective. You can also put in your normalized schema here. You can also have a Snowflake schema, but you're paying a penalty for that. So the compression is not so good, the joins take longer, and for the end user, it's more confusing because if I'm looking up something for the product, I have to remember, is this element, this attribute, this column I need, is it in the product table? Is it in the subcategory table, or is it in the category table? Because every table here become folders in your field list, right? What would you put between fact tables like actual expense and budget? Yeah, okay, 10. Very, very good. Depends on the need. That's the usual answer.
Sorry, I think you said just talk, right? So instead of typing, I'll just ask the question.
That's okay.
Because I think I get that, what you said about the one-to-many relationship. And yes, my model is slow because I'm doing a lot of two-way dimensions. So yeah, good point. And I don't like it, so I'm going to try to fix it. That's why I'm here. So, but yeah, I get you. But as soon as I want to visualize the numbers and I make a graph that says here are your actual spends and this line is your budget, then I get stuck because then it doesn't the filters don't seem to work for me when I put it into one graph. So maybe, I don't know, maybe you can try to, solve that.
So the budget is a very typical use case for the thing that the budget, the specialty with this use case is the actual numbers are really, really detailed. So in low level grains, we really have a timestamp there, or at least a date there, a product there, and so on. And the budget usually is not on this level, right? You have the more product categories where you do a budget, and for a whole month and not for the days, right?
Yeah, correct.
Yeah. So this is the difference in here. And this is something which is, if you know how to do it, this is easy to do in Power BI. This is really hard in products like Tableau because Tableau expects one table, and then you have this weird thing. Where do I put the budget? Do I put it on the first of the month, and then I don't have a budget on the daily level? This is like confusing. I've lost there's empty rows then in there. In Power BI, it's easy to do, and I will show this use case in the other talk. I will just make it really, really short here. So what I would do here first, you wrote, what's the connection between the fact tables? No connection between fact tables. Remember, the fact tables are the big tables. And if you don't join between those these big tables, this will be very slow. First thing. Second, and how do I join them? We are, what's the English? Confirmed dimension is this term from Kimball Group. Yeah? Confirmed dimension means I need a dimension which can filter one table and also the other table. So I need one common thing, at least one common thing to filter there. And what I could, for example, put is that I have then not only a product table, but I have a product group table. And this product group table, that the challenge in the modeling, can then filter the actual numbers and also filter the budget. So okay?
Yeah, okay. I think I need to make more of those supporting tables then that have the dimensions.
Yeah.
Okay.
So it's
thank you.
Especially if different granularities, you have these bridge tables, or you have a many-to-many relationship then between your product group, the products group table, which can then filter the product table and also filters the budget. So it filters the actual numbers over the product group table, filters the product table, which filters the actual numbers, and the product group table can directly filter the budget. That's the principle. Okay, does this answer your question?
Yes, it does, until I get stuck again, of course. But yeah sure. Great, thanks.
Yeah, these are challenges. I totally get this, and even me, working with data models for so long, I always also find how can we model this to fulfill the requests and don't make the model too complicated, but also allow to get all the information out. Because some of the models could restrict not the information you have stored, but it could restrict the way you can query the thing. Okay, other questions? Look at the budget to the daily. Yeah. So here is just writing what you could do, for example, in Tableau, that you assign then the budget to the daily level, like you split up, like divide by the number of days or something like that. Or just bring it at the total on one of those levels. But there's also the other solution. So when should I choose the star schema or the Snowflake schema? There's more art than more art than science. Okay, so the Snowflake schema has more tables because now the dimension tables also have references to other dimension tables. That means it takes longer to load because I have to load different tables. So instead of just loading everything into this table, I have to load from 3 tables. The filtering is also slower because if you think back here, if you filter product category, this first has to filter the subcategory, which filters then the product, and then first I can filter the effect table. So this tends to be slower. And the other thing is makes the field pane less intuitive because I have to remember where to find this product attribute in which of those 3 product tables or folders, so to speak. And if you want to build hierarchies, I don't how to say, like I don't use so much the hierarchies because you can always like put any attribute in your visual, so you don't need those hierarchies. This was a different story. If anybody of you worked with analysis services multidimensional, it was very important that in your model you provided the hierarchies because this database works with aggregation. So it needs to know what kind of things have a hierarchy, a natural hierarchy in between, so it can prepare aggregations so that the query is faster. If you then query the product category, most probably the database has prepared an aggregated value over the product subcategory product category to make this speed this up. This is not how Tabula works. So hierarchies are only makes it easier for the report for the end user to just pull in a whole hierarchy instead of pulling in those 4 different columns. Don't we keep budget and action separate tables? Yes, both should like. Yeah. Don't go with a single table. Yes, fully support this. Okay. And then I just had like a simple. I mean, for my laptop, when I prepared this, the laptop with 80 million rows, it had something to do. It's not huge, but it's not small either. So if I have one single approach, I have one single table, of course. So the model is really easy. One table, no relationships, no cardinality, no filter direction, easy to handle, easy to understand. With the star schema, I have 4 tables, like the territory, the date, the product, and the reseller sales. And with the Snowflake, I split up the product into subcategory and category as well. And what came to surprise for me, the model size for the single table is 200 megabytes, where the other ones is 84. So this is almost more than double. It's almost 3 times the size. And 3 times the size means it takes up 3 times the size on disk, 3 times the size in your memory. And also, like, yeah, scanning the memory, of course, will also take 3 times the size, even the time. Because even if it's memory, it's fast. But if I like take this amount of time to scan 80 megabytes, it takes almost 3 times the time to scan 200 megabytes, right? So it will be slower. So stay away from single table approaches. The relationships also stored, so when they provide the model and make relationships, Power BI is smart enough to store information about the relationship. This is like an index in the relational database. So it stores like a pair of keys here and keys here to make the lookup and the join and faster. This takes up size. So of course the Snowflake is then bigger than the star schema, but of course your mileage will vary depending on what kind of data you're having, what kind of relationships you're having, what's the cardinality, because this is important. And this is why it's so hard to predict the size of a model and everything with Vertipack and Power BI is because the compression is dependent on the cardinality of your columns. That means the amount of different values per column. So if you have like a table 10 billion rows and if a column there with male and female, let's think there's only, if you only store binary gender, only male and female, this can be easily compressed. On the other hand, if you have the same table, maybe you have in your effect table, you have a key. Some people do this, that they have a key in the sales table. So every single row in this table has a different value. That is a big cardinality. This cannot be compressed very well. So it depends on the content. So you cannot say like, if the data is that big, it can compress in this small, because it depends on other factors as well. lot of discussion. I will read this later on. And how can you build your model? How can you make a star schema or a Snowflake schema or a single table or denormalized normalized form? Use Power Query. Power Query is used to filter your data, choose friendly names, choose the appropriate data types, cleaning up everything if it's not already cleaned, and then you can flatten your dimensions. So if I load then those 3 Excel sheets or 3 tables containing the product, the subcategory, and the category, then I can use Power Query to look the things up. So I'm not, it's merging. So I'm merging those tables. So merging means that I take one table and the other table and I just put them side by side. So I enrich the amount or enlarge or make the amount of columns bigger by merging those. And this is what I then put in the product table, and this is what I load in the model. On the other hand, if you have a fact table, like if you open up Power BI desktop and open up a sample database. Yeah, I want to play around. Please give me some sample. Not sure if you ever did this. Then an Excel spreadsheet is opened, Excel spreadsheet, financials, and this is flat. So there's everything in one table. And then you would use Power Query to duplicate this information. So I would use the original table, and then I would make a reference to it and remove all of the text columns, but keep, for example, what's in there. Let me think. I mean, I think there's a customer ID and a customer name. I keep the customer ID there, and I keep all the numeric values, like the sales, cost of goods, and so on. That's my fact table then. Then I will reference this table again, and then look up, what kind of customer information do I have? Okay, there's a customer ID, and there's a customer name and the address. I keep those columns, remove all the other columns. And for the original one, I turn off the data load. So I then load, instead of the big flat single table, I load my 4, 5, 6, 7 tables, and then combine them in the model view. Any questions about that? Yeah, and that's, of course, there's always links to Alberto Ferrari and Markus Russo at SQL BI. Great guys. If you never heard about them, shame on you. Check out their videos, check out the web pages. They're really, really smart and do really, really good to the community with sharing the knowledge. Okay. So data dimension. I have 7 minutes to go, right, Augustine?
So it's scheduled until 7. So if you have a few more minutes to go.
Yeah. Okay. Yeah, very good. Then maybe we can also take a little bit about the data dimensions, or like make a break at after the data dimensions, discuss if there's any questions which could not be answered by the rest of you, and then see if you have time for the use cases. I'm good with that. Very good. And I think this is also the reason why I showed up so late, because I thought the meeting will start at 6 and the invite was just at half before 6, 30 before 6. That's why I just showed up a minute before. Misunderstanding. So data dimension. Why is the data dimension special, or why it is important? Because we need it for 2 things. One is for convenience, because the data we import in many cases only contains a date or a date timestamp. And that means that if I want to then filter by year, I have to do something in my report. In classical like reporting services where you connect to a relational database, you would then apply in your select or where statement. You would then like wrap it in the year function, year of the date, and then check if this is a certain year to filter it. Power BI, this is not really convenient, or even in reporting services with SQL, it was not convenient. So what we built here is we built a date table, which consists of a date for every single day of the year. So you need always full days, so 1st of January to the end of December, for all the years you want to use and report on. And then not only having this one date column, but putting in all the columns you need for filtering or grouping. So maybe a year, maybe a month in the format of a year-month number, maybe a month number, a month name, maybe in several languages, the weekday, the day number, the week number, maybe you have financial year and financial month and stuff like that. So this can be very wide. So don't be greedy at the dimension level. Tables, data as a dimension. So we can have a lot of columns. Doesn't really matter, because as mentioned, it's just a several hundred or several thousand columns. This can be good compressed. No issue here. And the other thing why we need it is for time intelligence function. So time intelligence means that your report user, your end user, wants to see like September or like August of 2021. And then not only the August of 2021, but maybe he also wants to see the July, just to compare and like have a difference between August and July in absolute numbers and percentages. And maybe you also want to see like the August of the previous year in comparison and differences. And maybe you need the year-to-date value, because August alone doesn't really help, but you need like all the values including since January to August. Stuff like that. This is time intelligence, and there's functions built into DAX where you can relatively easily use this, and all of those functions need a date table. And this date table has to have this consecutive numbers, so there are no gaps. So if you create this date table, please do not create it as a distinct list of your date column in your facts, because most probably you have some days where there is no transaction because there was like, we were on vacation, the full company was on vacation, or the weekend, or 1st of January, or other things. Yeah, the companies were closed down maybe in the pandemic, so you might have gaps, and those gaps would confuse those functions, and they would confuse it in this way that they don't complain, but the outcome is wrong, and it's really hard to discover that there's like one day missing of your data. So these are the two reasons why we need this table. And you should also mark it explicitly as a date table. It's only necessary if like the date key you're using is an integer, which is the best practices for data warehouses. Power BI, maybe not so much. So if you join your sales table and the date table, not via data type date, but use a column of data type whole number, for example, this is not unusual, then you have to mark it. In other cases, you don't need to have to, but I would recommend do it because it's really easy to do. And then you don't have to think, when do I need it? When don't I need it? Just make it a habit to always mark it. How can you create this date dimension? And again, we're back to the beginning where I mentioned Power BI Desktop was built for self-service. So even somebody opening Power BI for the very first time, they should have an easy life to build the first report with the right numbers. And maybe they want to apply time intelligence, but they never heard that they have to build a date table, and they don't know how to build a date table because they're totally new to Power BI. For them, auto date time was built. So this is functionalities that automatically Power BI looks up your data model, and for every single column in your model, which has a data type of date or date time, I guess, it's building a date table. So that means if you have like 70 date columns, because the order date, shopping date, maybe you also have like for your employees, you have a birth date in there. And maybe the system is like, if there's no date available, as long as we don't know the shipping date because it's just ordered but not shipped, some systems put them in like the 1st of January 1900. And those 70 date tables are then looking up what is the smallest and the biggest number in there. And then it will prepare a date table for that. So like for the shipping date, it will start at 1st of January 1900 and look up what's the biggest shipping date. It's maybe today. So it will build up to end of 2021. So 120 years worth of a date table. And this is a huge table. Now we're talking about huge sizes because it's 120 years. It's not just 10 years or 20 years. It's 120 years. And this is built for every single date table, date column in your model. That means we don't have just one of those tables, but we would have then 3, 4, or even 70 tables also. So this could be really huge. So even if like your data, your transactions are just like, some columns, some rows, the model could be huge. The Power BI could be huge, and even like big, coming in troubles with it. So as you're sitting here and learning about the data model, now I just tell you the auto date time is not built for you. This is built for everybody else, but not for you. If you build your data model, start up Power BI Desktop, please turn off auto date. And you have to do it right now, because as soon as you loaded the data and built your first reports, and in reports you're then using this auto functionality, there's this weird syntax where it says like date as date table, the date column, date, dot year, dot month, and so on. This is only available for this special date table. It's not available for the other tables. That means if you start building your reports with auto date on and then you then turn it off, then you will break your reports. All the reports referring to the month, year, quarter, or day will show error messages, and then you have to clean that up. So do this early, do this right now before you start building your reports. And the other disadvantage is, as just mentioned, this date table builder has an automatic hierarchy, and it's consisted of contains a year, a quarter, a month, and a date. And if you say, we don't report about the quarter, I don't need the quarter, it's there. You cannot change it. If you think you need also, for example, a fiscal year or you use weeks or whatever, it's not there. So you cannot, there's no template available for that. This is just built for you, but it's not really meant for, to change the logic there. So please turn this off. So what can you do then? Either you use the calendar function or the calendar auto function, or you load the date table from your source. So maybe you build one in Excel, or you build you have a data warehouse and can use the date table from there. Everything is better than the auto date time function. And then with the date, it's a little bit special because the date, this can also happen with other dimensions, but for a date, it's typical that the date can play different roles. So for example, you have in your transactions, we have the order date and the ship date and the due date and whatever. So it depends on your perspective, what kind of filter you want to apply. Do you want to filter the order date, or do you filter by when it was shipped or when it was due? So this is what's called role playing. We'll see an example on that. So the date Markus date table is like that. So you go to, I think it's an you have to be in the data view, not in the model, either in the modeling, but not in the reporting. Sometimes the report always changes. I also have trouble to remember where it was. But there's some element here, Markus date table, and then you can just make sure that this is clicked. If this is not checked and you click there, you get this window, and then you have a list box here where you can choose the column of date of data type date. And usually you only have one, so this is easy to execute. To press OK, and that's it. And then you're on the safe side. If you don't do this, you could end up with problems. And this is what we can see here. And again, so I reopen things, and there's a batch file running, but I always forget that I then have to this one relationship. I have to close this one, because if I don't close it, the batch file will not open the next one. So, any questions so far? Thanks. Yes, please, everyone, turn off the auto date time. Yes, thank you for supporting me here in this.
And it was a question about slowly changing dimensions, which maybe you're touching with the next session in the user group.
No, I don't have any examples there. So maybe, what's the question there?
Just regarding the examples of slowly changing dimensions in data modeling in Power BI.
There's different approaches. So if you have a data warehouse, then the data warehouse will take care of that. And that means, so in short, slowly changing dimensions, there's different types. The mostly used one is like the slowly changing dimension type 2. Again, don't hit me. I did not invent this. Mr. Ralph Kimball invented this. He just numbered those types, and he made up the 2. And 2 means that I have different roles. So as soon as my customer moves, for example, from one country to the other, if I just reload the data, then the customer has a new country, and that means also for the past, if I look up the reports for the past, they will change. All the sales or the revenue done with this customer now moves from Italy to Germany, or the other way around. Maybe I don't want to do that. And then I would use this slowly changing dimension 2 to have 2 different rows. So all the transactions before he moved are referencing to a row with his name and everything the same, but still Italy. After he moved, there's another version of this customer, and all the rows, the transactions after this time, referencing the other row. So those are then going to Germany. So this is one way. And if it's just this, then you don't have to do anything in Power BI, because then the fact table already manages this. But there's also other things. That's why I'm asking for what kind of slow changing dimension you are referring to. What a more concrete question, then please type it in or let me know. Okay, what we're having here is this Markus date table. So what I have here is I have, again, very simple example, a date table with lots of rows here, a sales table, and for the sales table, for some of the dates, I have sales amounts. Really easy model. And then, of course, I can filter here, so I can change the filters and filter this down to 1st of October. Then, of course, I only see 1st of October, so the value changes in here. If I make this bigger again, then I see the full values. So not very complicated, right? And then I use time intelligence. And here, the exciting part comes. So I have here a measure defined, sales amount year to date, which is referring to date table. So that's the name of this measure. You can also see the result here. And what we can see here, this is year to date. That means that for the actual value, I only have one in October. I don't have any sales in this simple example for the 8,000 here. And the year-to-date means I take the value from the current month and add up everything from the previous year-to-date month. So that's why I also see the November here. So the 48,000 are the value from November, which is 0, empty, 0, plus the year-to-date value of the previous month. And you have 48 also here, because this is the 0 plus the 48,000 here. And this sum here, this total is totally right, because it's not summing up those values, because year-to-date means this is already summed up. So I see the last value appearing in my lines there is also repeating in the total. Easy as that. And now I have the same example. So first example was this one, where I have my date table, and that they are joined by the column date, and the column date is of data type date. In the other example, it's the very same thing, so same kind of rows. The only difference is here that the join is, or the filter is here on another column, a date key, and this date key is of integer, of a whole number. This is not a date. I have the date in here in my dates table, but the filter relationship is done on not a data type date. And what the consequences here is, if I see my date key, again, this is the same information, same things. I've just duplicated the table. The only difference is I did a date key in here, and usually the ID or key should be meaningless. So you just take numbers from 1 to whatever. For the date, we can make an exception. So it makes sense to have the date key like readable for us. So this is like, what is order structures? This is 20,191,001. Of course not. It's the 1st of October 2019, right? So that's what we see here. And if I then build the very same measure, take a look here. The measures are very same. So I have to, didn't discuss the other one, right? So I have this calculate here. With calculate, I can change the filter context. So I pass in expression. This is just the sales amount. And then I change the filter context on the date table to get the year-to-date value. So this is done by this calculate. And I do the very same over here. Again, calculate, take my sales, and then use the dates y2d function to change the filter on the date to get the year-to-date values. But look here, what we're having here, we only see values for October. So the year-to-date does not show the year-to-date. It just shows the actual value. And that's the problem. How can we solve this? Yeah, by marking the date table as a date table. So I think, yeah, I was struggling. Is it here? Is it here? Date table, help. I don't understand why they're changing the ribbons this way. So I think it should be here. So date table, and now I'm in the data view, and here we have this Markus date table. Markus date table. So I'm referring to the date key table. And then I just put in and select the date here. Okay, and that's it. When I now go back to my report, the year-to-date value, now go back to my, also the year-to-date value works for the date key version. So that's the thing. If you can't remember when to mark it, always mark it. That's the thing. Then auto date time, turn this off. If you don't turn this off, then all those tables automatically are created and you can't see them in Power BI. The only way is to use external tools, for example, DAX Editor. DAX Editor comes with this Vertipack analyzer, and in Vertipack analyzer you see all the tables, also the hidden ones, and also if you connect like with a tabular editor, you would also see them. And there's two options where to turn it off. One is at the current file data load. This only turns it off for the current file. If you want to make sure that the next time you open up a new Power BI report, this is also turned off, please go to the global section. There's also the data load. Data load is in the global section under the current file. And if you turn it off here, it's persisted for your user. And the next time you open up Power BI, this is turned off also for this file. And I would recommend doing this. So then there's role playing. And this example here, I have like one date table and I have two relationships between the date table and the sales table because I have an order date in here and I have a ship date in here. And this is called role playing. So because this date table shall either filter my order date, so it shall filter the sales table by order date, or it shall filter the sales table by a ship date, right? And how can I do that? So if I add more than one relationship, we can see here, I mean, this one is yellow and the one is white. This is not so important, but the one is a straight line and the other one is a dashed line. And the dashed line is the hint, this is an inactive relationship. That means this is not active. If I'm doing anything in my reports, this relationship is used, but the other one is ignored because it's not active. If I again forgot to close down my file here, so if I close this and keep talking, then the other file will start opening up, and I cannot activate this. So I cannot have two relationships between the very same tables. So between one table and the other, only one relationship can be active. And you think about it, it makes sense, because if I filter the date here and I have two active relationships, what would be the consequence? Like, should it filter by order date or by ship date, or only if the date is order date and ship date equals the same date? Doesn't make any sense. So what we can do here is having like this this model and use DAX to activate the relationship. How do we activate the relationship in DAX? Use relationship is the function here. So with use relationship, I can define for one certain DAX measure, I want to have the inactivated relationship activated for me. And this is open up in a second, then we can see this. So there is my two measures. So I have now in my model, let's go to the model first to see that really there's only one active relationship. Like there's two tables, two relationships. One is inactive, one is active, and if I double click on the inactive one, I of course can go there and then check this, mark this as active. But I can see here that there's an error message. Why is an error message? I cannot click OK. And it's telling me this is not possible. The model would not know what to do. So we cannot activate this way. But what we can do is we can use DAX and again calculate this our friend here. So we have one expression. This time it's not a measure, it's the sum function over a column. But the important part is here the use relationship. So in this measure, so when the ship quantity is used, I activate the relationship between the ship date and the date. Maybe you say, wait a minute, in the model view I cannot activate it, here I can activate it. Now that's because DAX is smart enough to see, the user asked me to activate the ship date relationship, and therefore I will implicitly deactivate the order date relationship. So still there's only one active relationship, but the inactivation of the other one is automatically done by DAX. And then I can or cannot, I would recommend also to have like a specific order quantity measure. So now it's not, and I can put use relationship and put in there, it says order date. I mean, this is already activated, so nothing changes here, but this may be less confusing because if you have a quantity measure and a ship quantity measure, maybe people don't know what's the difference. What's the difference with the quantity? So maybe it's a good idea to also name this order quantity and the other one ship quantity, and not just name one of them quantity. And what we can see here is that we can have then a date here, and depending on the measure, here I see the quantities assigned to the order dates, and that's the same quantity assigned to their shipping dates. And with this, I can also like build a chart where I have both of them in one chart. So I can see here there was like orders going up and down there, and there was shippings going up there, because in this visual, I can have two measures, of course. So I can have two values and get two lines for that. Maybe you're scared by DAX and saying, this is not really good. It's maybe also, it's not slower, but like, yeah, you don't like DAX. But maybe you want to have another solution. And there's another solution. There's only two solutions if you ask me. One is this like role playing by using DAX. The other one is having exclusively two tables here. So I have one order date, I have one ship date. Both of them can be built by this, depending on the same table. So you build one date table in DAX, in Power Query, in your source system. But then with the help of Power Query, for example, you load it two times. And one time you name it order date, and also all the columns, order date, order year, blah, 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 and then the ship date. Or you could use DAX for that. You can also refer to the other column and then rename the columns in there. And then I have two active relationships. So one is going from the order date table and the order date column to the order date column of the sales table, and the other one is using the ship date to refer to the ship date. If you're using this, our model is slightly more complicated. We have one table more in there, but then we don't have to use DAX. So we can always, or many times, we can exchange complexities between DAX and the model. This is also an important takeaway from this talk, I would say. So if we take a look on this one, then I have just one quantity There's no order quantity or ship quantity. It's just one thing, the quantity. And I can then filter it either by order date or ship date. And we have two different slicers. So if I need two different slicers on the same page, this is only doable if I have two separated date tables. That's the first thing. And also if I want to, for example, build a report like that, I want the order dates in the rows and the shipping dates in the columns to see like when was things when ordered in this date, when were they shipped. This is only possible if I have two tables. What I cannot do is that I have the order quantity and the shipped quantity in one visual. This is not possible. If I need this, I have to use the other version to have those two measures. Any question about that? Yes, because now we can open up the Q&A and then take a look to the budget use case. Are there any questions which are not answered yet? I totally lost track of the chat.
I think a lot of discussions were happening in a chat, so
yeah, which is a good thing. I like this. Yeah, when people are
most of the things are handled, and I'm always really surprised how basics like data modeling can start a lot of discussions.
Yeah, let's go. So if there's no open question right now, then I open up the budget use case. Let's talk about this. So there's something opening up. I'm not sure if this is the budget. No, the budget I have to open up separately. Yes. So there's one budget in here. Let's open up the file. In the meantime, I started to build up a virtual machine because like Teams is craving so much of the resources of my laptop, but this is still not completed and all demos works. Sometimes I have to still use my PC and then wait for the loading of things. But I think this will finish until I've explained the budget use case. So the budget use case is exactly what was it Tendor? I'm really bad at remembering names. Asked about, and this can be a really good example also for other use cases. So it's not only about budgeting, but the thing is that in a budget, that you have a budget and you have actual values and the granularity is different. So that means the point and the level on which you assign things is different. Actually, it's on day level, on product level, on customer level, and your budget maybe has month, has product category, doesn't even care about the customer. Maybe you don't make a budget per customer, or if you have not all of the customers. So this is the challenge here. We have information on two different granularities, and that means, according also to the principles in dimensional modeling, you should not put it in the same fact table. I mean, there are solutions. I've seen some discussions. You could like divide the budget value, so you simulate that the budget would be on this low granularity, but it is not. And when people then filter out portions of the days, then you end up with the wrong budget because you miss up some of the budget values, which is not right because the budget is for the full month, right? So in this case, we need two different fact tables. We could also call this model then a universe. If you have one star and another star, like keep thinking of there's many stars that you would keep then have a universe. This is also referred to this. And there's basically three solutions I found so far, what we can do here. So we can, again, use DAX for this. So treat as. We first saw this function. I thought this is a Greek goddess, Reatas, because there's no camel case, but of course it's treat as. So I can treat a table as there would be a filter applied from another table. So I can create a relationship on the fly, which is really powerful, but also be careful because Power BI, if you have a relationship in the model, it takes up space. It builds an index on this relationship. If you use treat as, there's no relationship, so you cannot use the index. So this might be slower, much slower than having an active relationship. Then we can have a many-to-many relationship depending on the version of WordPack you're using. Power BI, no problem at all. And analysis services depending on which version you're using here. And we could have a bridge table, which is the preferred solution for me. So it looks like this. So I first have like this use case. So I have a sales table, again, really easy, not really important what kind of values we're having here. We're having 4 groups and then we have a budget. And the important thing is we only have a relationship between sales and the product because this is on product level. So we have like 100, 110, 20, and 30, 100, 110, 110, 20. So for 30, we don't have anything. And if we then build a report on that, I have the month in here and I have the group in here. So we see then for group 1 in October, we have 33,000 because group 1 is the two of them. So A, B, and B, and A and B. Where's A and B? This is the 3. So this is 10 plus 20 plus 3. This is 33,000. And then group 2, this would be C and D. For D, we don't have anything, but for C, we have a value here, 120. C, 15,000 is here, and we see again the 48,000. Very good. But then there's a budget, and the budget we don't only have on product group level. So I made this easy in the case that I did the budget on the day level. So I tried to make it just concentrate on one of the relationships, but everything we're talking about here can also be applied on the date level and all the other dimensions. So just wanted to make it simple. So there's no relationship between the product and the budget, because if I try so, it will generate a many-to-many relationship, and maybe that's not what I want, and that's what not recommended. So in this case, I don't have any relationship, and that means the product is not filtering the budget. And we also can see there's something weird here, because the budget, we see 2 times the same value, right? And then we see 60,000 here, which is not the sum of this. So this is a clear sign that something happening wrong in the model. And of course it's wrong in the model because there is a filter missing. And why do we see 27,000? Because the group filter, which is the group from the product, is not filtering the budget. The month, the date, is filtering the budget. So that means that I have 2 times I have October here, so the group is ignored, but we have 2 lines with October. And for October, the budget is those 2 lines. You can see this is November down there, this is October. And 20 plus 7 is 27,000. So that's what we see here, 2 times, because we have 2 times the month of October. Why is it 60,000 down there? Because in the total, the only difference between single rows and the total is a difference in filter context. In total, we don't have any filter on the product, we don't have any filter on the date. That means we get 60,000 because if I sum up all those 4 values, 20 plus 7 plus 25 plus 8 is 60,000. That's what we see here. So how can we solve this? One thing would be to use tree days. That's the first thing I want to introduce here. Oh, 6 minutes to go. Okay, so we have again calculate. We have already have seen this. So then I have again sum of budget. This could be a measure, it could be a much more complicated thing, but I'm only interested in the budget. And then use tree days. And tree days has more or less 2 parameters. So first is the list with values. So I get a list of available product groups in the current filter context. And this list, might be 1, might be more, is then applied onto the product group of the budget. So with this, I generate a filter constraint, a filter relationship between my product group and the product group of the budget table. And this is working. So as we can see here, now we see for group 1, we don't have any budget. Remember, we go to the budget, we only have budgets for group 2 and 3. There's no budget for group 1. So that's why we here don't see anything at group 1. So it's empty. And for group 2, for October and November, we see the right budget. So this is the right budget. What's still missing is the group 3. Group 3 is not available in the product group table because I don't have any products right there. It's just a budget I built and there's no product in there. And I don't see this. This is still missing. Instead of tree days, if you don't like tags, you could also just go there and take the product group here and point it to the product group over there. This would then warn you that you're now generating a many-to-many relationship because the product group 1, for example, for product group 2 can appear many times here because product group 2 has 2 products, right? And there's also 2 products, 2 budgets in there. So it's also here. So it's a many-to-many relationship. And say, okay, I know what I'm doing. It's really a warning. Yeah, there's also learn more because you should stay away as much as possible. If I do this, this would be allowed to do the same without the tree days. Currently, this is also inactive. Let me see why this is the case. Make this active. You can't create because, yeah, because, so always if I'm running out of time, we make this active, but the filter action only is from 1. It's from product to budget. So that's what we need here. So we have an active relationship in a second, active, and it's filtering this direction. And so now I also have, like, without the tree days, if I go to the first page, I have the same effect here. So now I don't see the 27 2 times and the 16 at the end, but so this is better, but not a good solution, I would say, because we're still missing group 3. And this is what I would build with the bridge table. So let's go to the bridge table. Then 2 minutes, 3 minutes to go. So what I built here is I have a relationship between the product and the product group. So now I see not only the values for group 2 for October and November, but also for group 3. There's no actual values, but I see the budget here, and now this sums up. So this is what I would have expected in first place. So how did I build this? I built this with a bridge table in between. So I have a table in between. Instead of building a many-to-many relationship in the model, I resolved this many-to-many relationship to two one-to-many relationships. So the product group is filtering the budget, and it's also filtered in the product group, and it's only a one-to-many relationship, and it's only a single filter direction. How can we build this product group? Easily, either with DAX, Power Query in your source system. So if you take a look on the definition of this table, let's go there, the product group. Then this is just a distinct list of my product groups from both tables, from the product table and the budget table. So this is, if I make this bigger, what I take is just a list of my distinct, means a distinct list of my product groups from the budget table, a distinct list of my product group from the product table, and then I'm union them. So that means like appending in Power Query. I'm just putting them underneath each other. And then to make sure that's a distinct thing, I put also distinct here, but recently I found out that this distinct is not needed. Let's check this. As we are at it. So if we do that, then we get like an error message because table in, okay, for some reason this doesn't work. I don't have time, so stick with the first version here. And this is how I build this. So, and this is also like best practices if you are building like application database or whatever. Anytime you have a many-to-many relationship, you resolve this with an intermediate table, a bridge table, so-called bridge table in between. And that's it for today. So we had the introduction level. We had the one use case with the budget. So if you want to see the budget again, come into the other meetup, or be late if you don't want to see it again, and then you see the other use cases I present there. Any questions?
I think a lot of chat were happening, but if anybody has any question, just unmute yourself or turn on the camera. If not, so Markus, it was a pleasure listening to the session, although I listened it 2 weeks back in Zagreb. And it was a pleasure having you here. And yeah, people are also applauding so much. So just to share the thank you slide, and to remind you that all the recordings will be available again, as I said, on our YouTube channel. So if you missed this one, if you want to show it to some of your colleagues or friends, just share a link. And also, if you want to stay up to date with all the upcoming sessions, join us on a meetup page. And now you can join actually the next session just to stay with Markus and finish the evening together.
In 1 hour, yes. There's 1 hour break and then the other meetup is. So I need some dinner.
Thank you, Markus.
Yeah. Thank you, Augustine. Pleasure was all mine. Maybe see one or the other in the other session. If not, see you around in one of the next events.
Yeah, see you.